flies by so fast. Whoa. Time flies by so fast, but we still have a good semester left. So hopefully we can bring much more fun meetings this semester also. All our meetings and recordings and slides will be posted at acm@uc.org/archive. And if you haven't, please go to acm@uc.org/c and fill out the attendance form. It kind of helps us keep track of who has been attending our meetings as well as in the end of the semester itself, we do elections for the next exec board, and you need to have attended at least 2 meetings to be an eligible voter or even running for the election. And so this is how we keep track of all of that. So please, if you haven't yet, go to acm@uc.org/c and fill out the attendance. It takes like a minute, less than a minute. Um, our mission. Our mission is encouraging professionalism among tech enthusiasts in a collaborative fashion such that we can work together by facilitating learning beyond the scope of classrooms to develop innovative and inclusive ideas. So we want to bring you skills that you generally would not learn in classrooms, or at least introduce you to those skills, so that you can work on innovative ideas and do learning outside the scope of classrooms. I feel I've said this like, well, exactly 10 times now, um, but I think it's a great mission, and I've enjoyed being part of ACM and working towards this. What is ACM at UC? Hopefully by now you know what ACM at UC is, but if you don't, we're the student chapter of Association of Computer and Machinery at the national level. The way I like to describe it, it's just a bunch of cool CES kids or kids who are into technology coming together and doing a bunch of other cool stuff. What events do? We do a bunch of events which include social, professional, and also technical. So we have guest speakers and panels at general body meeting, kind of like today where Nishil is our guest speaker and talking about something that he's learned and is passionate about. We also do ICPC, which is Intercollegiate Programming Contest, which is lead code on a national or international level rather. Revolution UC, which I'll talk much more about later. We do a bunch of socials and also review sessions. Services, we have a Slack community, a Discord community. We also record our meeting minutes, and we have office hours right after this. Membership requirements, you just need to attend 2 meetings and sign in the form that I've mentioned before, and that's it. Code of conduct, we are dedicated to a harassment-free experience for everyone. And so do check out our code of conduct at acm@uc.org/conduct. But essentially, it all boils down to be cool and be nice to everyone. You also provide programming review sessions like we will at the end of the semester, especially for C++. But last semester, we also did one for Python. And we also have office hours right after this meeting at 8 o'clock. And since it is a snow day, it'll be all on Discord. ICPC will be this semester, but registration information is still TBA. Then here's the big thing, Revolution UC. It is coming up on February 26th, 27th. A lot of the people in this meeting are actually organizers for it. It is all virtual, unfortunately, but also fortunately, because I feel virtual hackathons can be just as much fun, just in a different way. We decided just because the rising cases in COVID, it's definitely a safer choice to just go all virtual. If you don't know what a hackathon is, it's 24 hours of coding, learning, and fun. You essentially just work on a single project with your teammates for 24 hours straight. We have 300 plus attendees, and you also get to connect with sponsors. Registration is open, and if you go to revolutionuc.com/register, you can fill out the form. It takes like 5 minutes for 24 hours of fun. So please, if you haven't yet, go ahead and register for it, and you can also get more updates on Twitter and Instagram. We also have a new TikTok account that I need to update over here. But all our TikTok account, or like TikTok information will also obviously be available on Instagram Reels. Although I think TikTok is a superior platform. ACM's community server. This is something that's led by our Vice President Piyush. We are building our own community server this year, which is very exciting. It will serve a variety of purposes. Something on our end would be saving ACM files and everything, but On more of the general member side, we will also use this for VMs and also games. Spoiler alert, we might use it for Minecraft. So definitely stay in touch with us. You can also join us and help build the server soon because we haven't started yet. But if you are interested in it, let us know ASAP because we can only have these many members helping out us with building the server. But if you're not able to, we will still document the entire process and make it available to you guys once it is completely built. Uh, we also have Slack. If you haven't yet, please join our Slack. That's the best way to communicate with us. And go to acmcincy.slack.com/sign up. And if you're not on Discord, also join Discord using this QR code. Discord is much less formal than Slack is, but you get the same information on both of these platforms. Although our officers are on Discord, and so are most of our socials. Other resources are just resources that I've talked about, and this meeting will be uploaded on YouTube. Next, the most awaited, the machine learning landscape by Nishil Faldu. So Nishil, if you want, take it away. And if you want, go ahead, share a screen.
See, okay. So I'm gonna wait, slideshow. Okay, yeah. Do you guys see my screen?
Yep.
Okay, as you guys already know that this event is in partnership with Google Developer Student Club, and I'm the president for Google Developer Student Club. Google Developer Student Club is basically a community just like what ACM is. We bridge the gap between theory and practice. We held technical workshops as well, and we aim to create production level projects for our communities. And the good thing about unique thing about our club is there's Google Developer Student Club all over the North America. So we are in Canada, and now the Google Developer Student Club is also spreading in parts of like the India and other countries as well. We have professional development events. We have Showcase Showcode, technical workshops, cloud study jams, and game nights. So yeah, and let's get started. What you're here for. So the machine learning landscape. Basically, this talk. So this is a very introductory or a basic introduction to machine learning landscape. It's very useful to people who are planning to get into machine learning or who have no idea what machine learning is. And this talk is also going to be useful because I've added a few things from my previous talk. That who all have already started into machine learning. We are also going to discuss a bit about the structure of TensorFlow. So stay tuned for that. So what is basically machine learning? There are two definitions which are really famous, and it's a part of literally every book there is about machine learning. The first one is machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Now we will see what this definition actually means, and the other definition is just for reference. It gets a bit complicated, so we'll not dive into the other definition for now. Right, so as we already mentioned, that machine learning is the art of programming where you are not explicitly programming or telling the computer what to actually do. So how is it really different from traditional programming? As the figure already suggests that there are rules and data in case of traditional programming. So let's take an example here. Everyone has a Bearcat card because we go to UC, right? So if you want to create an algorithm that recognizes a Bearcat card, what would you generally do? You will have a bunch of if-else statements that says, if the card is red, then it might be a Bearcat card. If the card has an M number, or if the card is a picture, then it might be your Bearcat card, right? Now that's called traditional programming, where you have a bunch of if-else cases and then you get your answers. So machine learning is totally different. We are not coding it in the form of a bunch of if-else statements. We are just giving it data and answers. So basically showing your camera or creating a computer vision algorithm, or just a basic algorithm where you just show the camera your card and the algorithm learns what your card looks like, what are the rules of the card, that if it's red, it might be a Bearcat card, if it's an M number, it might be a Bearcat card. So the algorithm learns the rules on its own. It's not a bunch of if-else statements. So that's how machine learning is different from traditional programming. Right, let's take an example of a rock, paper, scissors algorithm, right? Let's say if you were to code it traditionally, as you already know that an image is a bunch of pixels, or it's a bunch of zeros and ones, right, on the basis of their pixel intensities or on the basis of the brightness. So if you want to code the same thing into a machine learning algorithm, what you'll basically do is analyze those bunch of ones and zeros. You'll say, let's say if there are 4 repeating ones, it might be a rock, or if there are 4 repeating zeros, it might be a scissor. But what happens actually when you change the orientation of your hand? The pixel intensity also changes, right? So your rules also changes. Basically, you'll have to code a bunch of another if else statements, which is probably not robust if you're going to deploy the system somewhere, right? So you want a machine learning algorithm who recognizes how your hand looks like, or what's the position of your hand, irrespective of the orientation of your hand, right? Right. So given the examples of different gestures, your ML program can learn to name those gestures without explicitly coding that, if it's a bunch of zeros, then it's a rock. If it's a bunch of ones, it's a paper. We are not doing that here. The examples or the data which we are feeding, which are basically the pictures that the program uses to learn, is called the training set. Now, these is just the basic terminology that a machine learning engineer or anyone involved in machine learning uses. The task T here in this case is to identify those gestures, and the performance measure P can be the accuracy, that whether the algorithm was accurately be able to identify whether it's a rock, paper, or a scissor. So why do you want to use machine learning? You might see somewhere that why you want to use machine learning, basically because it creates a more robust system. You don't have to code a bunch of if else statements, and if something changes, you don't want to code another bunch of if else statements. You want your system to learn over time, and so it does not even cause a lot of problems when it comes to deployment as well. So consider how you write the previous identification task using traditional programming techniques. First, you would consider what a particular gesture looks like. You might notice that some pixels are brighter than the others in certain gestures. Like we already mentioned, that bunch of ones and bunch of zeros. You would try and recognize those patterns. Then you would try and write a detection algorithm for different pixel patterns that you noticed. You will test your program and repeat the above 2 steps until it is good enough to launch. Now, even if you launched, it's not robust. Now that also sounds like a difficult problem as well, right? Your program will be just a long list of complex rules, a bunch of if else statements, or maybe a bunch of loops as well, which is tough for maintenance. Machine learning can automatically learn those pixel patterns, which might be good predictors for those gestures. So you don't want your code to be of multiple VS Code pages or multiple VS Code files, right? You just want a succinct, a good enough, like let's say a 5 to 10 lines of code, and you're good to go. So the ML program will be much shorter, easier to maintain, and more accurate. In traditional programming approach, you will always have to write new rules, but in machine learning, the algorithm can update itself, can learn itself, then you can deploy it again, and so forth and so on. Consider coding a speech recognition with traditional programming. Now, I wouldn't know where to begin with traditional programming, like how to convert the audio text into a bunch of ones and zeros, because the computer only understands ones and zeros. So the best solution there is for you to code an algorithm which just learns by itself. So let's go through some best decision practices. So according to me, it's important to learn about the learning algorithms. So learning about learning algorithms is equally important than knowing what tools to use. So some people just dive into machine learning, knowing about TensorFlow and scikit-learn, and they just start playing with the tools from the first day itself. But I would say first learn about the learning algorithms, like what kind of algorithms are in the industry, and learn about the math involved behind those algorithms, and then try hands-on, then try to code those algorithms. And also at the same time, machine learning terminology is also equally important for you to read further or learn more things about machine learning. So let's dive a bit into different types of ML systems. First, are there any questions so far? Can someone monitor the chat for me, Josh? If you can, please.
Yeah, I don't think I have any questions so far.
Okay, even if there are any questions, feel free to stop me. That's fine.
Okay.
Right. So let's dive into different types of ML systems. It's always good to know the different categories that, because machine learning is ever growing and there are different categories. I'm not really sure what category would you be interested in. So let's dive into different categories. Now, machine learning can be divided into categories based upon how they are trained. So whether or not they are trained with supervision, we'll see what supervision means in a few minutes. So it can be divided into supervised, unsupervised, and semi-supervised, and reinforcement learning, whether or not they can learn incrementally on the fly, which is online and batch learning, and whether they work by simply comparing new data points to the known data points, or instead by just detecting patterns in the training data and building a predictive model. So let's see what these actually mean. First of all, let's see what supervised or unsupervised learning means. Now, as the name already suggests that, when you have a training set, you feed the algorithm, the training set, and you also have the labels. So let's say if you're teaching the algorithm how a Bearcat card looks like, that means you're showing the algorithm what the Bearcat card looks like. You're feeding the images, and you're also telling the algorithm that this is a Bearcat card. And if you are, let's say, feeding an image of a blue card, then you're also telling the algorithm that it's not a Bearcat card. So you're giving the training data set as well as the labels. So that's called supervised learning. Now, unsupervised learning, as you would have already guessed, it's directly the opposite of supervised learning. There is just the training set, and it will try to derive different categories. We'll see how unsupervised learning looks like in the upcoming slides. So important supervised learning algorithms are where we are not going to dive deeper into the details of these algorithms, but it's good to know what kind of algorithms are if you want to get started, just reading about those. So linear regression, logistic regression, k-nearest neighbors are some of the supervised learning algorithms. Unsupervised learning, the training is not labeled. So if the training is not labeled, then what exactly are we learning in this case? How is it even a learning algorithm? So let's say you're given this data set on the screen shown here. Can you find some structure in the data, right? So you will see that there are four groups. Four groups, right? So a machine learning algorithm will actually see and identify those four groups, and maybe if you use some fancy libraries, it will also plot those four groups for you, like put circles around those groups or divide the whole graph into four groups basically. So that's called unsupervised learning, finding some structure in the data. Important unsupervised learning algorithms are clustering. Clustering is one category of unsupervised learning algorithm. So k-means, dbScan, HCA. There are a few other algorithms as well. We'll see the images and they'll be more clear, I guess. Some visualization algorithms and association rule learning are also a part of unsupervised learning algorithms. Let's see some images so they're more clear. Clustering, basically, as I already mentioned, that you're already given the data, you're feeding the data to the machine learning algorithm, and it's producing some structure for you. Like this data set has four categories. So it plotted these three lines to, so it gives you a structure. It gives a structure to the data, basically. It gives you four categories. So that's called clustering. Dimensionality reduction. Now, sometimes, let's say your data set is 300 dimensional. Like, let's say if you wanted to describe a car, how would you describe a car? So car, let's say it has a windshield, it has wipers, it has four wheels. So these are like different features, right? It's already three-dimensional now. The car will have multiple features as well, right? Or any object will have multiple features. So it leads to a multi-dimensional data. Now, if you want to reduce that multi-dimensional data to a three-dimensional one, because we can only plot three-dimensional, two-dimensional, and one-dimensional data, right? So we can use some dimensionality reduction algorithms, which will enable us to plot the 200-dimensional data into, let's say, 300-dimensional data. Anomaly detection, as the name suggests, it's detecting anomalies. So you will feed the learning algorithm a bunch of normal training instances. Let's say you will you will show what a right Bearcat card looks like, and then all of a sudden you'll just jump in, put in an anomaly, and if you plot the training instances, it will show that it's far away, it's not really similar to the previous training instances, and it will say that it's an anomaly. So that's how anomaly detection works. Semi-supervised learning. So labeling data is time consuming and costly. Like, let's say you have a bunch of images of rock, paper, scissors, right? You just have images, you don't have labels to those things. So it can be a bit difficult to label all those things, right? Sometimes there will be plenty of unlabeled instances and only a few labeled instances. So there are some algorithms who can give a structure to your data, and on the basis of those few labeled instances, it can label all of these things. Now, a real world example that I'm not sure if Google Photos uses this, I'm not really sure, but I'm pretty sure that Apple Photos app uses this. So if you guys are using an iPhone, feel free to try it right now. It does one amazing thing, right? So semi-supervised learning, yeah. So it does an amazing thing where it will create a group of pictures which look similar. So let's say if you put in a bunch of pictures of myself, then it will create a cluster of those pictures, and then it will ask you to label only one of those images. And if you label only one of those images, it will end up labeling all of your images, basically. So that's how semi-supervised learning works, because you are only labeling only one of them, and it's just labeling others on the basis of the categories that it has classified into. Reinforcement learning. Now, reinforcement learning is very intriguing. It is a very powerful beast, and this is a learning system where an agent which selects and performs action. Now, the learning system will get rewards on the basis if it takes a good action, if it will get penalized if it takes a bad action. The learning system must learn by itself what is the best strategy, called a policy. So this picture will make things more, it will give you more clarity, basically. So let's say there is an agent, it's learning to detect whether a fire is harmful or not. And if the robot, it goes near the fire, it will receive minus 50 points. So it will know that it does not have to perform that action. And it will try and go close to other objects nearby rather than going close to the fire. So that's reinforcement learning for you. Now, for those of you who are wondering if you want to start with a machine learning project, and that's how you want to begin, learning about machine learning algorithms, it's probably a good idea as well. So these are like some of the basic steps that you carry out in an end-to-end machine learning pipeline. Now, this goes from having the data set with you, you not knowing what ML algorithm you can employ, and it goes to you launching, monitoring, and maintaining your system forever. So these are like the few basic steps that I personally like to follow. I've taken this from a book which I've cited in the last slide. So you can also buy that book, read that book online as well. So look at the big picture, get the data set, play with the data set, try to get some insights, select a model you want to train. Now, how you will know which model to train? You will basically have to learn about different learning algorithms, and you'll just know that, okay, this might be the right model. And if it is not if it is not the right model, you probably could try a different model, and then you just hit and trial. You just see what kind of model works best for your data set, or which gives a better accuracy for you. You present the solution, you see if there are any fine-tuned modifications that you want to make, and then you finally launch, monitor, and then you finally launch the system, and you keep monitoring as the new data comes in. Any questions so far before we dive into some frameworks which makes the programming of machine learning algorithms easier for you?
Yeah, I think Piyush had a question of asking, can you give a quick description of what dimensionality reduction looks like? Does it group similar features? Is that what it is?
So basically, dimensionality reduction is basically used to just reduce the dimensionality of the data set. Now, if you were to take an example, let's say, let's say we have a lot of features when it comes to a data set having predicting the mileage of a car, right? Now, a mileage can be predicted with a number of features of the car. Let's say how many what is the size of the gas tank that the car has, or maybe other features like size of the gallon tank is one. The next feature can be just I would say, what can be the other features? How fast your car runs, or how much fuel does your car actually burn per second. Now, let's say you have five such features. Now, you cannot really plot a five-dimensional data set, right? If you have five values like 1, 0.1, 0.2, 0.3, and 0.4, you cannot really plot a five-dimensional data set. So what a dimensionality reduction algorithm will try to do is it will try to find correlation between two of the features or three of the features, right? So let's say maybe, just assume that the gas tank size and the fuel it burns every second is somehow related. And if they are somehow related, it will be reduced down to one value. So now your data set is actually four-dimensional, and then so on and so forth. It will find one more feature which is related to these two features, and it will try to reduce a data set to three-dimensional data set. So that's what basically a dimensionality reduction algorithm tries to do, and then it will just plot the data set. It will not try to cluster the data set like the clustering algorithm does. For that, you will have to use a clustering algorithm. But when you actually plot the data set, the good thing about plotting is, or good thing about humans is, you can actually see those categories when you plot them with different colors. So that's how dimensionality reduction algorithms are used.
Okay, that makes sense.
Okay.
I had like a small follow-up to that too.
Mm-hmm.
So can taking the best features also work instead of clustering?
Definitely. So now that comes down to what pre-processing steps you apply to your data set. So if you say, let's say the size of the gas tank does not matter, right? Then you can just omit that and it just reduces your data set to three-dimensional. It's just a personal preference at that point. But if you think that, you don't really want to do that and still preserve all the data because we are not sure what data points are actually useful, then people generally use dimensionality reduction algorithms, and they will try to preserve as much information as they can.
Makes sense.
Okay.
Thank you.
Anything else? Okay. So let's talk about TensorFlow and Keras, because a lot of people here maybe know about machine learning and they have already started using these fancy libraries like TensorFlow and Keras, right? So Keras is basically, or Keras, as some people like to pronounce, is a high-level deep learning API. Now, deep learning, so machine learning is a field of algorithms, so many algorithms that you cannot even keep account at this point of time. Now, one of the algorithms is neural networks, and neural networks is really famous, used in speech recognition systems, computer vision algorithms, all these days. And so basically, that's the field of deep learning. A field of neural networks is deep learning, and TensorFlow and Keras makes it so easy for people to just for people to code these neural networks, right? So people who have already the knowledge of how neural networks work, or they have already coded it before, I think this information would really be beneficial for you, how TensorFlow and Keras are actually structured. So Keras is basically a high-level deep learning API. It just makes it so easy for you to build, train, evaluate, and all sorts of neural networks in like a few lines of code. It's very easy to use, very flexible, and it is beautifully designed because it was a research project. It was a research project carried out, and it's beautifully designed. To perform heavy computations required by neural networks, Keras needs a computation backend. Now, if you ask Keras to, let's say, uh, compute some operations related to calculating a gradient of a graph, or let's say calculating differentiation, it won't be able to do it because it does not have a computation backend of its own. So that's where people actually use TensorFlow or libraries like TensorFlow or CNTK, which is the Microsoft version of Cognitive Toolkit, Theano, and other stuff. We are just going to focus on TensorFlow for now. So after initially Keras was just a research project, TensorFlow then decided to use Keras and give TensorFlow its own implementation of Keras, so which also gave Keras a lot of other useful features as well. Also, I would like to mention that people like to use PyTorch as well because of its Pythonic nature, but I am not really familiar with PyTorch, so I cannot really talk about it, but I'm pretty sure there are some people already in the meeting who know about PyTorch and can answer questions about PyTorch as well. Right, so this is how the basic structure of Keras API looks like. Keras API is at the forefront, and you can use a computational backend on the end. It can be CNTK, Theano, TensorFlow, and after TensorFlow or Google gave TensorFlow its own implementation of Keras. It really looks like this. Keras API is the high-level API. TensorFlow has its own low-level Python API, and it has its own implementation, tf.keras. Right. So why is it actually important to learn about different things which the TensorFlow provides before jumping into TensorFlow? Being programmers, we are so used to reading codes and we are always used to just Googling stuff like what does this actually mean, right? So people initially I was really confused between the words like sequential and functional. I did not really know what it actually meant, these lines of code. So I researched a bit, and I feel like it's very important to learn the nature of the TensorFlow API before jumping into coding your machine learning algorithms or your neural networks, right? So basically, let's talk about sequential API. Let's say if you wanted to code about neural networks, if people already know what neural networks are, you already know that it consists of different layers, right? So let's say this is the first input layer, this is the dense layer, this is the dropout layer, and this is the dense layer again, right? We don't really need to go into what a dropout layer means or what a dense layer means. It's fine. So what does the sequential API basically do? As you can already see that the code already says tf.keras.models.sequential. So what the sequential API gives you, it's like you can pass a list of layers to the sequential API. So it's like, let's say your first layer is your input layer, so the flatten is your input layer, dense is your next layer, dropout is your next layer, and a dense is your next layer. So that's what a sequential API does. It tells you to just give us a list of layers, and it will create the model for you, right? Now, sequential API made sense to me, complete sense to me. But then sometimes when I used to Google the code, I always used to encounter some different kind of code as well. Let's go to the next slide. Now, this code is literally different from what we encountered here. It does not even include the word sequential. So how does this code work? And I was so confused that I had to do a lot of research about it. And that's why I keep telling that it's very important to learn the structure of TensorFlow as well. So it's like we already learned sequential API where you just pass a list of layers. But let's say you were supposed to code a neural network which has a structure like this on the right-hand side. An input layer, all the data from the input layer goes to a hidden layer, and also it skips a few layers. It also goes to the concatenation layer. Then it goes to the hidden too, and then it goes to concatenation, then it goes to output layer. Now, if you would think, you wouldn't really be able to do this with the help of the sequential API or the sequential code where you can just pass the list of layers. You wouldn't really be able to do it. So that's why you use the functional API. Now here what you do is you just mention layers like like variables, like or like functionals. That's why it's called a functional API, right? So it's keras.layers.input. It's literally a function. It returns an output and it stores it in the input variable. Now that output is is actually passed to the hidden one layer. So you do the same thing. The hidden one layer, you pass the same output that you received in the first layer to the second layer, and then you store that in a different variable. You pass the same variable into a different function that is called in the next line, and so on and so forth. So now what this gives you is the functional API basically gives the capability of coding a neural network of any structure you want, right? It can be as weird as the one on the right hand side. So that's what functional API is used for. So if you encounter two different types of code, next time don't be confused. One can be related to a sequential API and one can be written in the form of a functional API. There's another feature that TensorFlow provides, which is called the subclassing API. Now, some of you might say, what if I want to code my own model and I don't want to use what uh, Keras or TensorFlow provides? What if I want to use something of my own? Then for you, it is the subclassing API where you can code your own model. The only thing you have to keep in mind while coding your own model is you have to pass in keras.models.model, which is the subclassing API, as a part of as one of the parameters of the class. So that's how the subclassing API works. We won't really go into the details, and the call function is also really important. So if you want to really learn more about how to create custom models, this is the way to go, using the subclassing API. Now, some general information, like you already know, that sequential and functional API are declarative. You just declare layers. You just tell the TensorFlow architecture. You just tell the TensorFlow that these are the layers. Feed the data, and you get your results. Advantages are model can be easily saved, cloned, and TensorFlow knows what TensorFlow can run those check types. TensorFlow can run those typing errors, or it can check types properly. It can catch errors. It can do everything on its own. But what are the disadvantages is basically it does not give you something like conditional branch, right? Let's say if the data, all the values in the data set were greater than 5, then you want to implement a different layer. And if the values were less than 5, then you want to implement a different layer. Now, a sequential and a functional API cannot really do that. So for that, you might want to code your own custom model. So the subclassing API basically can be used for that. This is just general information about TensorFlow architecture. Most of the time you will be coding with the high level APIs. You don't really need to know about the low level stuff that goes on. But if you want your code to be really efficient, then I would suggest, or if you are looking to just code custom things like your custom loss function, your custom activation function, your custom matrix, custom layers of the model, or the whole model itself, I would recommend that dive into the low level structure of the TensorFlow, learn how it's actually done and everything. Now, why is it called TensorFlow? Because it's made up of tensors. Now, what are tensors? Tensors are basically something like NumPy arrays. So if you really dive into the low level stuff, I would really recommend to learn about tensors and how their operations work out. TensorFlow op is basically similar to how NumPy operations work, but there are some significant differences, which I would really recommend to look into if you are dealing into low level stuff. And some of the resources is the first resource is the Hands-on Machine Learning book with scikit-learn and Keras and TensorFlow. It's literally one of the best books that I've encountered so far. I've read half of the book and it's just amazing. It just goes into the detail, teaches you enough math that you need for machine learning, and it's just amazing. Hugging Face is a repository, basically stores a bunch of models. It's growing so fast. I just visited their page after let's say 6 months, and it has grown so much that I'm just blown away by their growth. So Hugging Face is one other resource that you can refer to. They have amazing courses as well. So that's all from mine. That's all from my side. Do you guys have any questions?
Yeah,
My screen. Yeah.
I don't see any question in the chat, but I was wondering, what's some or even one project that you've worked on with where you've used machine learning that you thought was pretty cool? Um, so let's start with that one first.
Okay. I think the how I got started with machine learning, it's a pretty basic data set. It's called the California housing prices data set. That's how I learned like the really basics of machine learning. So it just try to predict the houses in California on the basis of location, on the basis of how many bedrooms it has. It's a really basic data set. That's one of the projects that I really like. And one another thing that I did for my part-time was an NLP research project where it was sentiment classification. We had some reviews from one of the clinics, and we were trying to identify what's the hidden sentiment in those reviews. So let's say if it's a good review, we rate it as, we just want the model to classify it as good, or it's a good review. On the basis of the sentiment score. And if it's a bad review, then we want the model to say that it's a bad review. So yeah.
Oh, nice. And another question was, hold up, might as well switch on my camera. But another question was, this was a great talk and very informative. So if someone wants to know more about machine learning, I know you provided some resources, but what would be the next step for someone to get more into it?
As I already said, it's always so machine learning is a lot about math as well as it is about programming. So I would say get your linear algebra clear first. All those matrices operations. You don't really need to dive in the depths of linear algebra. You can just dive into the depths when you cross that bridge. So but really the first step would be just learn about different algorithms. So let's say there are some of the algorithms that I already cited. um, you can use that as a base list to get started, and then when you start work on a project, I already give you like a list of things that you need to take into consideration. So start working on projects, because that's how all the computer scientists learn everything, right? So that's the way to go, I would say. And literally, I'm not even kidding. I have read more than half of the hands-on machine learning book. It's amazing. It's an amazing resource for anything related to machine learning. And it's literally goes from the basics. So it's literally from zero to hero for machine learning. So yeah, I highly recommend that book to anyone.
Is there a YouTube video for that book?
Well, okay, there was a person, there was a YouTube channel that was trying to give summary of all the chapters. I'm pretty sure the YouTube videos are still there, but I'm not sure if all the chapters are available there. You know?
Okay,
Yeah.
no, that makes sense. I'm sure a book is much more helpful, but I don't have the attention span to read a book.
True. No, true, but it's really helpful. And if you don't have the attention span to read the book, the author also has the code repository of all the codes available in the book. So if you really want to dive directly into the code repository is also there.
Awesome.
Yeah.
There's also some more resources that some people have provided in the chat. So thank you so much, Brandon and Akshay, for providing that. Anyone have any more questions? All right. If not, thank you so much for a great talk, Nishil. It was so fun learning so much from you. And thank you for coming. I know it takes a lot of preparation to give these talks, so really appreciate you coming to ACM. And is there anything that you want to talk a little bit about Google DSC when your meetings are, or just like give that last push?
Oh yeah, definitely. Google DSC basically have their meetings every Wednesdays at 6 p.m. We are still in the planning phase for the semester. We're kind of a new organization. We have only been on the only been on the campus for like a semester. we're still in the planning phase, but feel free to join our Discord channel. I'll put the link in the chat after I quit this meeting. So yeah.
Awesome. Thank you so much, Nishil. With that, I can go ahead and share my screen and kind of close out the meeting. I was trying to search like the repository that you said before. I wasn't just trying to search hug. uh, But to close out, if you have any ideas for this year, which isn't a whole lot left, but we still have good amount of meetings left. So if you have any ideas, or if you yourself want to go for a talk, feel free to reach out to me or anyone else on our exec, and we can try to set something up for you. If there's any social that you're particularly looking for, definitely tell us, and we can try to get that done. Um, and moreover, join our sibling organization, including Google DSC now. IEEE had a great talk today from Dr. Jason Heikenfeld from 1819. ACMW, Women in Tech, and also IT Student Association all keep doing great stuff. So definitely try and go to their meetings as well. Um, if you want to lead a talk or a workshop, like I said before, feel free to either DM me on Slack or mail me at my UC email. Our upcoming meetings, we have a Intro to Hackathon meeting on for our next ACM meeting, which should be, if I'm not wrong, 17th February. But that might be a wrong date because I just threw that in. But definitely come through for that meeting, especially if you're planning to attend Revolution UC, because you'll get a lot of information on what to expect in a hackathon, what to expect in Revolution UC, and how to make the most of your experience, especially if you've not attended a hackathon before. Another plug is ACMW and WIT have a secret Valentine event going on, so I think the registration's still open. Definitely go check out either their Instagram or any of their Slack or Discord spaces to take part in that. And you can see our full schedule at acmaduc.org/meetings. Get to know ACM members. Come hang out with us in Discord after this. Join a voice channel. Share anything that you are up to. I think recently someone started a blog, and so they shared the link to their first blog, which was so cool to read. If you're working on a project, definitely share that. Talk about what's your favorite language, any classes that you're taking right now that you really like, any classes that you need help with. Feel free to message either in Slack or on Discord. Lastly, thank you so much for coming. It's so nice to see so many people come. Hope you all had a nice snow day. And if you haven't yet, definitely record your attendance at acm@uc.org/c. All right, with that said, I'll stop recording and hang out for like another minute in case someone has anything.